Hey guys, this video is going to go over the law of cosines. Now, just like the law of sines, this is a strategy, a method we can use when we're working with non-right triangles. Now, the formulas look a little more complicated than the ones with law of sines were, but I think that they work out a little nicer. We don't have any of those like weird situations with the missing angles where it was ambiguous and we had one, two, or no solution possibly. So here's how the law of cosines works, okay? In order to use this, you have to have side angle side or side side side. Now, these formulas that you see down in the box are all technically the same thing. The reason that there's three of them is just to show you that, hey, if I was solving for side A, I would use the top equation. If I was solving for side B, I would use the middle equation. If I was solving for side C, I would use the bottom equation. Now, the reason that that's not really important is we can just call the sides and angles whatever we want them to, okay, as long as the sides are matching up with their opposite angles properly. So really, you only need to know one of these. There's no point in memorizing all of them. Pick one, and that's the one that you're going to want to remember. Okay, so it's all really relative to the side you're looking for. Now, the first part of it, if we just focus on the top one here, this looks a lot like the Pythagorean theorem. Okay, so it kind of starts off that way, but then we've got this minus 2 times BC times cosine of A. So the way I remember it is that the side you're looking for goes on one side. The two other sides that you know go on the other side of your equal sign. The B and the C, whatever letters go here, are going to match up with whatever letters you had right here. And you're always going to be taking cosine of the angle across from the angle you're looking for. Now, I know I just made a huge scribbly mess on the screen, but when we go through an example, it's going to make a lot more sense to you. So let's see what we have here, okay? We have an angle with its opposite side, and we have two other sides. So this would be side angle side. I have a side, I have an angle, and I have a side. So we can use the law of cosines here to find x. Okay, because I'm solving for x, that's going to go on the left side. Okay, so x squared is equal to my two other sides squared and added together, minus 2 times my sides that I know times cosine of the angle across from the side I'm looking for. Now, what I would do is I would just square root this whole thing, and I would just type it into your calculator all at once to save you a bunch of small intermediate calculations. So I would type it into your calculator exactly like this, and it's going to just spit out that side length. So yeah, it's a little bit more long-winded, but it works every time. There's really not any complications that come along with it. It's a pretty surefire way of finding a missing side with relative ease. Okay, so if we go ahead and do this, you're going to find that that missing side length is 21.8. So let's check out another one here. Okay, again, I have a missing side I'm looking for. I've got the angle that's across from it, and then I have my other two sides of that triangle. So side angle side, we can use the law of cosines again. So we know that if we go back here, I wrote this first step, but it wasn't really necessary. If I know I'm looking for x, instead of just doing x squared equals all that stuff, I'm just going to jump to the step below where it was x equals the square root of all that stuff. So x is going to be equal to the square root of 15 squared plus 17 squared, my two other sides, minus 2 times those same sides, times cosine of the angle across from the side I'm looking for. Okay, so again, type it all into your calculator at once. Make sure you've got parentheses all in the right spots, and you're going to find that this missing side is 10.8. So let's look at an example where we're finding a missing angle here. Like I said, this is going to be a little more straightforward than it was with the law of sines. This time we have side, 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 and we're looking for angle x. So the important thing to note here is that 8 is the side that is across from the angle we're looking for. So this time it's going to be a little bit different of a setup. Now my equation is going to be 8 squared, because that's the side opposite the angle I'm looking for, equal to my two other sides squared and added together, minus 2 times those same sides, times cosine of my missing angle x. So what's really important here is that this angle and this side that's on the opposite side of your equation, those have to be opposite of each other, okay? And opposite meaning like across from each other on the triangle. If you don't have that set up properly, it's not gonna work. So now we have some more algebra involved to actually get cosine of x by itself. Once we get it by itself, we're just going to do inverse cosine, put it in the calculator, and there we go. So we're going to have to subtract the 11 squared plus 10 squared. Okay, and then a lot of people try to add 2 times 11 times 10 to both sides, but keep in mind, since it's multiplication, we really have to divide both sides by that. So we're going to have really 8 squared minus 11 squared minus 10 squared, all divided by negative 2 times 11 times 10, and that's going to be equal to cosine of x. So really, we're going to be doing inverse cosine of all this stuff to find out what x is. Now let's simplify the number inside first. So 8 squared minus 11 squared minus 10 squared is going to give us negative 157. And then in the denominator there, we've got negative 220. So really, we're just doing inverse cosine of 157 over 220. So if we do that, we get 44.5 degrees. And you don't need to check anything like you did for the law of sines. There's no other possible angle measurement. This is the only one. So yeah, it was a little more calculation intense, but you don't have that weird case that you have to consider anymore. So let's look at another one here where we're looking for a missing angle, and then I want to look at a word problem. All right, so again, find the angle you're looking for and its matching side. That's probably the most important thing you can do before you set up your equation. So now I'm going to do 16 squared is equal to 13 squared plus 5 squared minus 2 times 13 times 5 times cosine of that missing angle x. And then I'm just going to solve for cosine of x. Okay, cosine of x is going to be equal to 16 squared minus 13 squared minus 5 squared, all divided by negative 2 times 13 times 5. So I'm going to simplify this first, and then we're going to do inverse cosine. Okay, so in the numerator, let's see what we get. Looks like we're going to get 62. And then in the denominator, we're going to get negative 130. So now I'm just going to do inverse cosine of that value. and we get 118.5 degrees. So let's look at a word problem here, because word problems with non-right triangles can be a little tricky. All right, so it says Tom and, or let me start over. Let's go ahead and draw a non-right triangle before we get started here. That'll make it so we can kind of label things as we go. Okay, so it says Jack and Tom started a tree and began running apart with an angle of 23 degrees between them. If Jack runs 50 meters and Tom runs 38 meters, find the distance between them. So let's think about what's going to make up each vertex of the triangle here. Okay, one of these is going to be the tree that they start at, and then they both run in opposite directions and they end up at a certain spot. So let's say Jack runs and ends up over here. And let's say Tom ran and ended up over here. Okay, well, we know that they began running apart from that tree with an angle of 23 degrees between them. So that would make this angle 23 degrees. We know that Jack ran 50 meters from the tree, which would make this 50 meters over here. And we know that Tom ran 38 meters, which would make this side 38. Now, the distance between them is going to be this side here. Okay, that would be a straight line between the 2 points they ended at. So again, this is law of cosines. We have side, angle, side. We're looking for the side opposite of the only angle we know. So x is going to be equal to the square root of 38 squared plus 50 squared minus 2 times 38 times 50 times cosine of 23. Okay, and once we have all that in there, again, we can just grab our calculator, type it in, and we find that Jack and Tom are now 21 meters apart. All right, guys, I hope you found that video helpful. Let me know if you have any questions or concerns, and have a wonderful day.